Hello dear students. Today I am explaining about Poynting vector theorem. So before starting this, you must remember that it is very important topic regarding Nagpur University. Now we have to start this theorem. For that we have to consider Maxwell's first equation in point form for towing bearing field. So it is given by this delta cross H. This is actually nabla, but I am for simplicity I am calling it delta cross H equals to J plus del by del T of D. this this J is current density and this D is flux density, electric flux density. Here it is not bar, it is actually this tilde. Here it is also this tilde. This shows that the field is varying with respect to time as well as with respect to distance. Now we have to take dot product of E tilde on both sides. So taking dot product of E tilde on both sides. So you have to write like this: E tilde dot delta cross H equals to E tilde dot J plus del by del T of D. Now I am expanding right hand side. It is E tilde dot J plus E tilde dot now I can put in place of this D as epsilon E. D is actually it is given as epsilon E. So it is del by del T, since D equals to epsilon E. Now on left hand side you can see this expression. This can be solved using a vector identity. So a vector identity is given as delta dot A cross B. Consider any vector A and any vector B. So if I multiply A and B using cross product, and if I take a dot product of this bracket with delta, this is given as B dot delta cross A minus this A dot delta cross B. So we can remember this formula as: first this delta is multiplied with A, this delta is multiplied with A here, minus this delta is multiplied with B. So first this delta is multiplied with A here, and this delta is multiplied with B. So and wherever we multiply with A we have to write B, and wherever multiply with B we have to write A. This method of remembering, for remembering purpose we can remember like this. So this is vector identity, and if you see the left hand side, it is E, it is a vector dot delta cross another vector. So here we have this vector dot vector cross another vector. So if I write my equation in terms of E and H, replacing this identity in terms of our E and H, I can write like this: delta dot E cross H is equals to H dot delta cross E minus E dot delta cross H. So I can substitute this E here. I can take the value of E from this equation and I can put here. So the value of this E will be like this: E dot delta cross H is equals to H dot delta cross E minus delta dot E cross H. So I can put this value in this equation. So this equation will look like, I am putting this equation here, this value here. So I will get like this: H dot delta cross E minus delta dot E cross H. So this is the left hand side, and on right hand side I have E dot J plus, I'm taking epsilon by outside, so it will be here I forgot a dot, it is dot product, so here there is a dot, so it will be E dot del by del T of E. So now I have to keep this on left hand side, and I will take this on right hand side. This will be like this: delta dot E cross H equals to E dot J plus epsilon E dot del by del T of E, and this will become minus H dot delta cross E. So this delta cross E is actually Maxwell's second equation. We can get the value of this delta cross E from Maxwell's second equation. Maxwell's second equation is given as delta cross E equals to minus del by del T of B, and we know that B is actually mu H, so I can write like this: minus mu del by del T of H. So I am putting this value here. So equation will look like this: equals to E dot J plus epsilon E dot del by del T of E. Now here I have minus sign here, and here is also minus sign, so both this minus sign will get cancelled and we will get a plus sign here. It will be like this. Simultaneously I am taking this mu outside, mu, and I am writing this like this: H dot del by del T of H. Actually the value of delta cross E is minus mu del by del T of H. If I put here, it will be like this: H dot mu del by del T of H. So I have taken this mu outside, so I can mark a bracket here. This is dot product of H and del by del T of H. This is dot product of E dot del by del T of E. So I have to solve this bracket first, because these two brackets resembles, so we will solve them separately. So I am writing this bracket only: E dot del by del T of E. So we can see that these two have the direction. This E also has direction, and this also has direction. So taking dot product of same vector, both E's are same, so dot product of same vectors gives only magnitude. This will be like this. So if I take with epsilon of, I will get like this, epsilon E del by del T of E. The direction will remove. We can understand this with the help of any example. Consider a vector A dot vector A. So if I expand this A, consider this A is in x direction, so this will be like this, magnitude of A into AX dot magnitude of A into AX. So I can take out magnitude outside, magnitude of A into magnitude of A into AX dot AX. So this dot product will be 1. So answer will be mod of A, magnitude of A into magnitude of A. If I remove this sign, my mod sign, I can remove this bar sign also. This will be A into A, that is A square. So similarly here we have taken dot product of these two. So here the mod sign will remove, simultaneously the bar sign will also remove. The direction will remove, only magnitude will be there. So now I am adjusting this equation like this, epsilon by 2 into twice E. I have multiplied and divided with 2 del by del T of E. This looks like that this look like a result of derivative of E square, because E is a function of time. E is a function of time, so its derivation will not become 0 because it is a function of time, and the E square, derivation of E square will be E square twice E into derivative of E. So it will be like this, epsilon by 2 derivative of E square. So I have taken the source from this result. Derivative of A square is twice E into derivative of E. So if I take this epsilon by 2 inside, I will get like this, del by del T of epsilon by 2 E square. Similarly I can solve for this mu also. So I am writing mu H dot del by del T of H. This will be equals to, their dot product will result in magnitude only, mu H del by del T of H. So I am adjusting mu by 2 into twice H del by del T of H, and this will be equals to mu by 2 del by del T of H square, and finally del by del T of mu by 2 H square. Now these two values I have to put in this place, so I will get this equation here like this, minus delta dot E cross H equals to E dot J plus this value del by del T of epsilon by 2 E square plus del by del T of mu by 2 H square. Yes, now I am taking integration on both sides with respect to volume, because I have to remove this delta sign. So this can be removed using divergence theorem. So for that, before the first step should be integration with respect to volume. So I am taking integration on both sides with respect to volume. So it will be minus integration, volume integration, del dot E cross H equals to volume integration E dot here it is dV with respect to volume, E dot J dV plus volume integration del by del t of epsilon by 2 e square dv plus del by into volume integration del by del t mu by 2 h square dv. Now we are, as I already told, that I have to remove this delta sign. For that I need to take divergence theorem on both sides, on this side. The divergence theorem, it is given by this closed surface integration of I am writing the general expression d dot ds is equals to volume integration del dot d dv. This is divergence theorem. So if I change this equation, if I see this equation, it has delta dot e cross h, means delta dot a vector, means cross product of two vectors gives a vector. So delta dot a vector, here we have this delta dot a vector, so this will be same. So this volume integration can be converted into surface integration with this formula. So if I write this equation in terms of divergence theorem, I can write like this: closed surface integration, in place of this d, any vector, I can write this bracket e cross h dot ds is equals to volume integration del dot, and in place of d is e cross h. So I have converted this divergence theorem for our requirement, as per our requirement. Now I can put the value of this volume integration here in this equation. So this will be like this: minus closed surface integration e cross h, closed surface integration e cross h ds this is equals to volume integration e dot j dv plus the remaining thing will be same, volume integration del by del t of epsilon by 2 e square dv plus volume integration del by del t of mu by 2 h square dv. Now here we have to consider all the three terms. The first term, this is second term, this is third term. So if I concentrate or ponder on the first term, this is the first term, volume integration e dot j, this is the first term. If I see the unit of this unit of E is volts per meter into the if I see the unit of J, it is ampere per meter square. So if I multiply this voltage into current, this becomes actually watts power upon meter cube. So it is power density function, power per unit volume. So this gives instantaneous power. It means this term shows instantaneous power which enters the volume, because it is a volume integration, and the unit also shows that it is some power per unit volume. Meter cube is the unit of volume. So this first term shows instantaneous power which enters the volume, and it has a term J square. J is actually current density, so it explains about current. So this power will become a current in terms of current, so it will be like, it will be current loss. This will dissipate in terms of current loss, like this I square R. This will dissipate as I square R losses. The second term, if we consider the second term, the second term is volume integration del by del T of epsilon by 2 into E square. This term, in this term, the unit of epsilon is farad per meter, and the unit of E is volt per meter, but it is square, so it will be volt square per meter square. And we have one more thing, we have this del by del T. We have this T, the unit of T will be second, 1 upon S. And if I convert this farad so into I have to convert this farad towards the current. So for that we have to consider a formula. This farad is the unit of capacitance, and we know the formula capacitance is the formula for C, it is actually Q by V. The unit of Q charge is actually coulomb upon volt is some volt. This is capacitance, it is given by C by V, and the unit of capacitance is farad, so I can put farad as C by V. So this will be like this, 1 upon S farad. Instead of farad I can write C by V into this M, and this M square meter square, this will be meter cube, and to this volt square. Now this coulomb can be converted towards current, and we know the formula. This current is nothing but flow of charge per unit time. It is actually flow of charge with time. It is Q charge divided by time. A unit of charge is coulomb, unit of time is second, and unit of current is ampere. So I can put, instead of C, I can put C equals to S into A, A into S second. So if I put 1 upon S instead of C, if I put ampere second into volt square divided by volt meter cube, this second will cancel, volt, this will cancel with this, and ampere into volt becomes watt divided by meter cube. Again this is same as this. So this again explain, this second term again explain about the instantaneous power which enters the volume. This also explains the power enters the volume, but this power, it has a term current, so we can say that it is a power that it dissipates in terms of current. And this term has E, means electric field intensity, so we can explain about this term as this term explains about the power entering the volume in terms of electric field, means this power enters the volume through electric field. In electric field, the electric field carries the power inside the volume, and this power stores into the electric field. This power has store into the electric field. Similarly, we can concentrate on this third term. This third term is volume integration del by del T of mu by 2 h square, and this the unit of T is 1 upon S second, and the unit of mu is Henry per meter, and the unit of this H is ampere per meter, but it is square, so it will be ampere per meter square. Now the unit of Henry can be converted to, because we have already ampere, so now we need volt, so this Henry can be converted to volt. using this conversion. This 1 by s will be as it is. This volt, it will be volt second upon ampere. This is the actually Henry into 1 by m, it will be as it is. This ampere square per meter square. Now this ampere square, this square will cancel with this ampere, the second will cancel with second. Now we again have this term volt ampere upon meter cube, means watts upon meter cube. Again we got the same thing. The third term again explain about the power that has unit watt, and it enters the volume with H, means magnetic field. The first term, it explains about power that enters the volume, and it has a term current density, so it will be dissipated as current square, current loss. And the second term, it has E term, so we can say that this explains about power which is carried by E field inside the volume and gets stored inside the volume in terms of E. And the third term, it explains about the power, and this H term explains that the power enters the closed volume with the help of H, using H, and it gets stored inside the volume in terms of H. And if we concentrate on this left hand side, this E has a unit, it has a unit volt per meter, and this H has unit current, means ampere per meter, so it will be watt per meter square. It is actually power per unit surface area. It is actually power density function. It explains about power density function. So on the left hand side, it explains about power density function. It is defined as Poynting vector. It is denoted by P vector. It is actually Poynting vector, and it is given by E cross H. It is given by E cross H.